All right, so today we're going to be talking about cross-site request forgery. We're not going to have a lab in this video because this lab really plays hand in hand with the one we did in cross-site scripting, because it was kind of, the exploit was half cross-site scripting and half cross-site request forgery. And just to, kind of not take away from, that lab, I'm not going to repeat the same lab twice just because I couldn't really find a better example that would have made more sense. But let's just go ahead and jump into it. So what is cross-site request forgery? Cross-site request forgery, it's just letting attackers perform actions that a normal user is able to, and it's some unwanted action on behalf of the user. So this kind of diagram that I just pulled from Google is a pretty solid representation of what this might look like, and it kind of depends on a couple different things. It depends on, first, there needs to be some kind of relevant action that us as the attackers want to make use of. So something like viewing a post wouldn't really be considered relevant, but changing an email definitely would. The application also needs to be using session cookie-based authentication. So, it needs to involve one or more HTTP requests, and that authentication almost needs to be solely reliant on those session cookies to identify who's making that request. And then the requests that perform this action need to not contain values that are like unpredictable for us, or things that we can't just guess or find out in another way. So imagine, this application in this post request right here is allowing us to change our email by containing this parameter in the body. And it verifies that, it's legit with this session, this session cookie right here. The issue with this is if we can trick this our target user to click on our site, we could, have this form here that just sets up the same request, but it's going to end up using their session cookie to authenticate that request. So we're, forging a request as if it's coming from the user by making them click on our link somehow, by like social engineering or just sending it to them, or maybe cross-site scripting is the way you end up getting them to navigate to our page and perform the desired action. But, in this case, it's like, it sends the filled out form that changes the email to this value to the vulnerable site. The issue in this case is like they would have to click on that form to submit it, which we could just, add some kind of logic like on mouse movement or on mouse hover submit form. So it wouldn't be that big of a deal to add that in. Actually performing these, I want to add though, Burp Suite Professional has like a cross-site request forgery proof of concept generator that makes this kind of straightforward, because as you could imagine, right, depending on the post request that we're trying to send, it's going to be, we're going to have to make like different HTML depending on what kind of stuff we're trying to steal. There's plenty of online resources that you can use. Burp Suite has that plugin that you can use. And typically like this is going to be delivered with a cross-site scripting, like attack vector in the vulnerable application, just because that's a lot more consistent than trying to send an email to some user or a message and hoping they click on it. So let's start talking about like one of the most common defenses, which is CSRF tokens. So these are going to be like unique, secret, and unpredictable values that are generated by the server-side application that are then going to be shared with the client. So they would set this CSRF token probably like this. They would say they'd make a hidden type, and they would give it some kind of name and associate it with your user session. And then when you send any request, it needs to include the CSRF token in order for your request to be validated. Normally, this would be a pretty solid defense because you can make it difficult for an attacker to make a valid request without already being inside the browser, right? If this is not guessable and we can't figure this out in any way, it'll make it pretty difficult. So most of the flaws with CSRF token validation aren't really in this model. They have to do more with the implementation flaws you might run into. So flawed, like you'll see flawed validation in some of these examples. So the first one, like if your validation depends on your request method. So like in the last slide, it was using a post request, but as we've done before, right, you can just change a or the contents of a post request into a GET request by adding them to the URL sometimes. And in this example, we could include this, still query the email change endpoint and just put the, the parameters in the URL, and all of a sudden it doesn't really care. So that would be a flawed implementation that checks the CSRF token based on the based on the request type. You also might see validation that depends on whether or not the token is there. So like if you submit a request without the CSRF token, it doesn't perform the check. Obviously, that's kind of a big issue because it would be kind of ridiculous to not let somebody into a building if they had the wrong key, but let them in if they didn't have any keys. So, you know, that's the kind of example I'm going for with why the token's presence. It's weird. You wouldn't expect it to be the case, but you might find that flawed implementation somewhere. You also might find that tokens either aren't tied to a session, or they're not tied to, either they're not tied to a session, or they're tied to some kind of cookie that is non-related to the session. So if it's not tied to a session at all, a website might be set up in a way when you submit a request, it checks if the token is in like a database of all the valid tokens for all the other users, which means even if you're not the target user, as long as you have a valid CSRF token, your request will be submitted properly, which kind of defeats the point because then anybody could make a request for someone else using their own CSRF token. If the token is not, or if the token is tied to some cookie that's not the session cookie, the example I've got right here is like you've got, you know, the session cookie here, and you have a CSRF key cookie, which these things are different from each other, the token and the CSRF key cookie. But, you know, it kind of works, but it kind of doesn't. If the token in the body of the request is linked, you know, to the CSRF cookie instead of the session cookie, we might be able to perform an attack if we can just inject this CSRF key cookie that's being validated. Because, right, it's harder to inject like this token that we don't know about, but if this token is linked to this cookie that we know about, we could have our form submit the CSRF token and this data here, and then we could just, you know, in addition to passing the session cookie, if we have like cross-site scripting, we could just use the cross-site scripting to inject the CSRF key cookie into the victim's browser. And then something else you might see is if the token is duplicated in a cookie. So if you're just doing it based on the cookie that you set, I mean, we could just submit our own CSRF key and parameter after injecting the key. So if we just inject this cookie in and then serve a matching CSRF parameter or CSRF token, then it would be trivial. So all those are just examples of like flawed validation. So if you're doing validation properly, which is basically just don't do these, you're not going to run into those same issues. Just try to make sure that it's being validated in a way that makes sense, right? You're validating it with the server-side list of valid tokens that are mapped to individual users' sessions. And then that being said, there's another defense or set of defenses that we can talk about. And these are first like same-site and refer-based defenses. Now, when we talk about like same-site cookies, we need to kind of talk about first the difference between a site and an origin, because it can get pretty confusing. For the purpose of same-site restrictions, the date or a site can be defined as a top-level domain, so like a .com or .org, in combination with some other part of the domain. So like HTTPS : would be the scheme, and that would also dictate like what port it's going to be running on. And if the target URL was like, I don't know, docs.google.com, google.com would be the site, because that's .com would be the site because it's the top level domain. And then other parts of the domain like google.com would be part of the site, but like docs.google.com might not be cross-site, might not be considered the same site as slides.google.com or something like that. Also, a request coming from HTTP going to HTTPS would be considered cross-site because the scheme is different. An origin is a little bit more broad because like sites could include multiple domain names, but origins can only account for one domain. So two URLs would have the same origin if they share the same scheme like HTTP or HTTPS, but they also need to have the same scheme, the same domain name, and the same port. So those distinctions are kind of meant to be made when we talk about like same site cookies, because you'll need to know exactly what, you know, dictates coming from the same site. Now that we've talked about that, there's 3 levels of same site cookie settings. There's strict, there's lax, and then there's none. You don't see none a lot because a lot of browsers, like I think Google Chrome, since maybe it was like 2021 or 2019, I don't remember the year, has been setting lax as the standard, like SameSite cookie, just as a security measure for everybody involved, right? Now, it's not instant, right? It does take some time to kick in, which we'll talk about in a second. But I would say just assume that by default it's going to be lax. And the restrictions that are set on these like lax same-site cookies are the browser will only send cookies in cross-site requests if the request that that it's being triggered is using the get method, and if the request came from a top-level navigation from the user. So this makes some of our CSRF attacks different, right? Because now, okay, it has to be a get request, so we're going to have all of the post data, like in the body, have to be in the URL now. And we're going to need to make sure that the user is doing some kind of top-level navigation to trigger it. So we might have to use some fancy like on-mouse hover or somehow trick them into clicking on a submit button on our site. But strict is a little bit more difficult. Or actually, before I talk about strict, I want to talk about, so the way that Chrome implements lax restrictions by default is it's not actually like always on by default. It's dormant for the first couple minutes. And that's designed to stop messing, or to not mess with like single sign-on mechanisms that rely on those cross-site requests. However, if you as a developer explicitly set the same site cookie to lax, that won't be the case. So, just keep that in mind. Same site restrictions, basically no cookies in cross-site requests. The browser will not send any cookies in cross-site requests, period. That's what strict is for. You might be able to bypass this if there's something about the web application that can allow you to trigger some kind of, request, or you can forward some kind of request internally, or using cross-site scripting if you're able to store something there that can send the request for you. But, that's going to be pretty dependent on your environment. So, you're gonna have to choose your battles there, but browsers don't often consider client-side redirects as like being different from normal. So cookies should be sent there without too many issues, because they're just going to be seen as, the same kind of requests that the application's already sending. And then referrer-based defenses, these are pretty short and sweet, but the referrer is just an optional header that contains a URL for the web page that's linked to whatever resource you're trying to request. So if I'm changing my email on vulnerable.com, referrer would be vulnerable.com, or wherever I just came from. So that's one way to kind of verify it, but obviously like you can set the referrer header in like a meta tag of an HTML page, which kind of countermeasures it. So it depends on how that referrer header is being validated. And sometimes you can we might be able to bypass validation by taking advantage of how it's used. If the application validates the domain starts with or contains a certain value, you might be able to use a subdomain that you're in control of to mess with it. But that's most of it. I mean, those are just some of like the other defenses you'd have to think about. And the countermeasures aren't like, some of them are specific, but most of the time it's going to depend on the environment you're in. As far as prevention goes, I know this looks short. There's actually a lot we have to cover here. And there was just no sense in trying to fit it all in slides because it's just going to be dumping information. But basically, just don't do any of the misconfigurations that we talked about. So when you are setting up your CSRF tokens, just make sure the token is unpredictable and really difficult to guess. It needs to be tied to a user session and nothing else. And the token needs to be strictly validated before any kind of sensitive action is performed. Try to make sure that you're using up-to-date, cryptographically secure random number generators to make sure that your tokens are actually unpredictable and hard to guess and you don't just feel like that. Try to transmit these as hidden values in the HTML. Do this really far away from user input sinks, just in case they're able to, overflow into other values and parameters and maybe set their own CSRF token that's approved to be valid, even though it's not. An alternative or another approach could be like you could put the token in a URL query string, but it's a little bit less safe because that can be displayed on screen within the browser. You can transmit that with HTTP referrer headers sometimes, and it gets logged on the client and server side, so I would avoid doing that. Try to validate tokens by storing them server side with the user's session data, and subsequent requests should verify that the token that you're using matches and is associated with that user's session. And you have to perform that regardless of if it's using HTTP, regardless of the HTTP method being used or the content type of the request. And then as far as strict SameSite, use it whenever you possibly can. In addition to the token validation, you want both of these things. But just use SameSite restrictions for every cookie you use. It gives you a lot more fine-grained control over when the cookie is going to be used. So somebody can't, it's going to be a lot harder to forge requests that way. And ideally, you just use strict by default and then only ever lower it to lax permissions if there's like a legitimately good reason for doing so. That's all we've really got for today. If you want to, test this a little bit, there's a few machines on Hack the Box like Bank Robber that I covered in the cross-site scripting video, or another one, Ouch, with 2 O's, like OOUCH. That video is quite good, or not that video, goodness. That machine has an example that's a little bit more fine-grained than this, and has a few more, it's a little bit more detailed, but those are some resources I'd direct you at. But that's all we've got for today. I'll catch you in the next one.